Hello and welcome to TidyX episode 134. TidyX is a screencast where we go through and explain how our code works. My name's Ellis Hughes.
And my name's Patrick Ward. Thanks for tuning in with us for 134 episodes. We always appreciate everybody who logs on to watch. If
Oh,
you like
yes.
what you see, like and subscribe on the YouTube channel. Drop us a comment down below.
Love it.
Additionally, if you feel like any of our work has positively impacted you, we do have a Patreon page. We're super grateful for anything that you'd like to contribute. That said, let's jump into 134. And actually,
Yeah.
134 is fueled by someone like yourselves who left a comment on the YouTube channel and said, hey, thanks for the episode. And I like to use DT tables, but I need to know more about conditional formatting.
How does that
So I've
work?
got probably like 6 different conditional formatting examples here. We're going to go through each one. The first few are going to be basic, and then we're going to roll into some stuff that's a little bit more complex, but does give you, the developer, a ton of flexibility when building tables.
Exactly. And the hope is after this, we're not going to go through every single option there is formatting in DT. There are a number of them. But by the time that we're done with this episode, you're going to have the tools and understanding of how to apply the rest of these formatting tools that exist.
Yep.
So let's dive right into this. So we're going to first load up our library and set up some data that we're going to be using. So we're going to, of course, load library tidyverse. And since we're talking about DT today, we're going to use the library DT so that we can make our data tables. We're going to generate some fake data for us to use. So we're going to set a seed so it's reproducible. And we're going to just make a very, very basic type of data set here. We're going to use Tibble and we're going to make a column called athlete. It's going to literally just be from the letters data set, which is baked into base R. It's going to be capital letters from A through the 15th letter, which I don't recall off the top of my head. I'm not great at the alphabet, apparently. We're going to assign several different, we have now 15 players, A, B, C, D, blah, on. We've got positions. There's going to be centered, forwards, and guards. And we're going to be calculating some metrics around them. Say we measured across 3 different days. So we're going to randomly generate some values to fill and to populate columns day 1, day 2, day 3. Next, we want to calculate the weekly average. So let's say across these 3 days, what was their average value across those 3 days? So we're going to use mean, and we're going to use the C across function in combination with rowwise to calculate the mean values across day 1 through day 3, as well as calculating the standard deviation across days 1 to day 3. And then finally, we're going to calculate a CV percentage, which is the standard deviation divided by the weekly average, and we're going to round that to 3 decimals as well. And then finally, we're going to ungroup to get rid of our rowwise. So we're going to run that real quick in order to get our DAT data set. And now we're going to jump into our first very basic table. So this is going to be the basis of all the conditional formatting that we're going to be doing. So Patrick, take us through this one.
Yep. So in order to create a data table, we need our data frame, which we call DAT, and then we're going to pipe it to this data table function. Literally in DT, as you've seen in previous episodes, you could just do DAT and then do data table function, and you got a data table. That is completely interactive. We're going to do a little bit of styling here, though. So within the data table function, we're going to say, hey, we want to have a title. It's called caption. I don't know why, but it's the title. We don't want the row names because they don't offer us any additional context. And we're going to just throw some cell borders on there so that we kind of have a bit of a grid looking table so that the eyes can kind of follow along pretty easily. Then the next thing that we're going to do is we're going to use this options argument that you're going to see a lot. And within options, you're going to pass lists to it, which are basically telling the table how you want it to behave. I think it's writing some kind of JavaScript wrapper underneath to make these things work, because you can directly put JavaScript right into this options argument if you wanted to into one of the lists. For ours, we're going to say that we want to center the table, and we pass it the targets. The targets here, this is something that's super annoying for data table. I don't know why. If you're inside of the data table function, the targets are the column numbers are counted from an index of 0. So if you have 10 columns in your data set, the indexes are 0 to 9.
Yep.
Once you're outside of the data table function, if you wanted to call a column number to like format percentage or something like that, they're indexed from 1 to 10. I don't know why. It's just something to be aware of. It's super frustrating.
Yeah,
Anyway,
it's JavaScript. JavaScript is
it's
zero indexed,
yes,
and R is one
yeah, zero
indexed.
index, exactly. So that's a little bit of styling. And then all we're going to do is slap some creative column names on here. So we've got athlete position, day 1, 2, 3, weekly average, weekly standard deviation, and a coefficient of variation, which is reflected as a percentage, though not yet. We're going to turn that into a percentage here in a second. But that's our basic table. And even just with this, looks pretty decent. We could probably roll with that. But someone wanted to know about conditional formatting. So let's jump into that.
Yeah. So conditional formatting or some basic formatting is actually relatively simple. So you use they're prefixed with format, and so dt : format. Some forget the word for after, but it's not postfix.
Suffix.
Suffix.
Yeah.
There we go.
Yeah.
Format and then some suffix is going to tell you what formatting it's going to be doing. So in this situation, format percentage tells us that we're going to be formatting on percent. We pass the column that we want, and here we pass the actual column name that we want to be formatting. And then in this situation, we're only worrying ourselves with digits. Of course, there's a number of other options, but what we're really wanting to do is just, hey, round it to 1 decimal and you're done. So let's see how that looks in our data set here. And so now we can see our CV percentage column is now a nice percentage. Before, it was that awkward kind of 0 to 1 percentage values. It's kind of obnoxious, not super simple for people to read and understand. But as soon as you've now applied that format percentage, it's like, yes, 45.9%. I get that. I understand that. And it looks real nice. So the way you can learn more about this and other formatting functions included in DT is you'll go to their man page. So dt : format percentage with the question mark in front of it is going to bring up the help page for all of these styles. So there's a number of them. So they got currency, string, the format percentage that we just talked about, format rounding, significant digits, or signif, date, and then styling. So there's a lot you can do with the tools that they provided for us. So let's go into, so that's just like rounding the numbers and whatnot. But I don't think that's the only styling that we care about doing. We actually also care about making it look pretty, because that's usually what we're talking about when we're talking about formatting. Patrick, how do we do that?
Okay, so there's a few ways to do this. We're going to use that format style function, which is right there in the helper helper window. So we're going to take our original basic table. So we've already created that table that we want. We're happy with where it is. Now we're going to start to style it and conditionally format the columns. So we're going to pipe in the format style function. And the arguments that this takes is, one, is going to be what columns do you want to format? So we're going to format the athlete column. So that's the athlete's names or the letter representative of their names. The two arguments that you're going to want to specify when you're doing conditional formatting. If you want to color just the text itself, use color. If you want to format just the background itself, use background color. In this example, we're going to do both. Okay, at the same time. And then in future examples, we're just going to do one. Style equal. So there's two main functions. When you're coloring the text or when you're producing background colors for conditional formatting, the two functions you're going to work with are style equal or style interval. Style equal is exactly as it sounds. It's going to equal some exact value. So think factor variables, a specific number, something like that. Interval is going to put a cut in your data, and that's going to be for continuous numeric values, and we're going to show that in a second. So here, what I have is style equal, and I've set the levels that I'm interested in coloring, which are athletes B and athlete F. And the values, I want to make sure that both of them have their athlete or B and F colored in red. And I'm going to do the exact same thing, but I just want to make sure that their background is gray. So I want it to pop a little bit. So it's going to be red text with a gray background. And we run this, and there we see they pop right out. There's athlete B and athlete F. Super easy to do.
Nobody else is styled.
Nobody else is styled. Everything is normal there. Now let's take a look at coloring the position groups differently. So Ellis, why don't you walk through that?
Sure thing. So let's jump on that. So we're going to use again format style, and this time we're going to be coloring the position POS column. So that's why we pass POS there. And now, rather than doing again, we're going to need to specify the exact values that we want to be coloring. Unfortunately, you can't just calculate on the values already in the table. You need to provide those externally. So we know dat is what we passed into the data set, and so we are going to get dat $pause to get the positions, and we're going to call a unique on that. So if you call that, you're going to get a vector of the 3 values, center, forward, and guard, or G. And then we're going to pass the values. And so what we're saying here is we want center to have the background color of light green. We want forward to have a background color of yellow, and we want guards to have a background color of light blue. One thing to note here, and in both of these scenarios, we need to make sure the exact same number of values get passed as the number of levels that we're entering in. If it doesn't, it's going to throw an error and go, hey, I don't know what I'm supposed to be coloring this other thing as. So you need to pass the exact same number in. So let's run that. And there we go. We can see that the centers are colored in their light green in the background color and then forward is yellow. And then if we go on to page 2 where all the guards are, there they go. They've got their light blue there. And so that's how we can, with multiple different ways, either with the values within the table and only specifying a couple of them, or if we know we want to color the entire column, we just need to pull out what are the unique values of that and then pass the same number of colors. Mm-hmm. So now that's not the only type of coloring we want to do. Sometimes we don't know the exact values we want to color, but we want to have an interval to call out something. So like a significant p-value maybe, or if you're looking at these training values, if a player was way above and beyond what you'd expect. So how do we do that, Patrick?
Okay, so we're going to stick with our basic table. We're going to pipe in, again, the format style function. The column, this time we're interested in the coefficient of variation. So the standard deviation represented as a percentage of variance. Okay, color. So we're not dealing with the background color. We're not filling in the cell. We're actually just coloring the text here. And instead of style equal, this time we're going to say style interval, and it takes a value or a argument called cuts. So here we're drawing a line in the sand at 0.4. Everything below 0.4, we're saying go ahead and color that text black. Anything that's above 0.4, go ahead and color that text in red. And if we run this, we should be able to see a table that gives us all the 0.4s above in red and all of the below 0.4s in black. Pretty cool.
So it's super easy to add that in.
Super easy to add that in. We can do the exact same thing and just actually switch out color for background color. We keep the cuts the same. We've changed it to white because a black background kind of makes it hard to read. So now we have reds and whites, and that looks pretty cool. And we can even then go through and add color bars. And so a color bar is like if you've ever used conditional formatting in Excel and they have the little sideways bars. So the largest value in that column is going to fill up all the way. The smallest value will have none. The way that we do that is we set the background color, and instead of style interval or style equals, we use style color bar, just as the name sounds. The data is going to be the week average. So that's the data it's a vector of the data that's actually coming from the column that we're interested in coloring. And we're just going to color it in this light blue kind of hue. So when we run this, we're going to get some color bars. And similar to, I believe, if I recall, in Excel, you're going to see that the bars start all the way at the right and then they fill to the left. So if we went ahead and sorted this column, we'll see that 59 has no coloring because it's the smallest. And then if we click sort again, we're going to see that 88 is filled completely because it's the largest, and then 80, 76, 73, which there are 2 of, and those are equal, and so on and so forth all the way down the line. Mm-hmm. So that's a little bit about some simple ways of using style, format style, and then background and or color to fill the back of the cell or color the text Now let's get into a little bit of advanced conditional formatting where you can do some neat stuff.
Yeah. So Patrick, why don't you set up the scenario for this?
Okay, so let's pretend with that we're dealing with some training data for the week, and we know for our population that the training demands have a weekly mean of 70 with a standard deviation of 10 for our team historically. And so we're going to create a z-score, and then we're going to make a highlight of, I think it's like 0.4. Yeah, we're going to make a highlight of any of the athletes that fall outside of a certain range, a pre-specified range. So the first thing, we just calculate our z-score. We take that week average minus the mean divided by the standard deviation, and there we go. We have a bunch of values that are negative and positive. We're going to create a new basic table. The reason we did this is just to make sure that we kind of add that new data in there with the z-score. So rather than continually having to add that in as the examples build on. So it's the same table though. You go ahead and run it. The only difference with this table is that we have a new column. We have a z-score column, and I don't want my user to have to see that z-score, but I want to use the information in that z-score to color other columns. So within the options, I set this list and I say visible equals false. And then I tell it the target. Remember, if you look down there in the console, it says Tibble 15 by 9. Remember, we're indexing starting from 0. So the z-score is actually in column 8 per the DT package, column 9 if we're counting normally 1 through 9. But so we're going to say make that column visible. Other than that, this is going to be the exact same table, except for that new argument. We can see it there. And now we can do some coloring using the context of that hidden column, but influencing the table that the user is actually starting to see and visualize.
Yeah.
And so here we are. So this is one way to do it. We'll show two different ways. I'll take you through the first way. We're going to use format style as we have before. We previously passed in the column that we're interested in coloring, which is weekly average. But now we have a new argument called value columns, and we're saying, hey, I want to color weekly average based on the information contained in weekly Z, which I've already said is an invisible column for my user. All of the same information now is the same. Background, we're going to color the background. We're going to style interval. So we're going to make some cuts. We're going to say anything below negative 0.4 in that z-score is going to be that pinkish color. Anything above 0.4, positive 0.4 is going to be that greenish color. And then everything in between is going to be white. We need 3 values here because we have 2 cuts. So we have a below, a middle, and an above. And so if we run that, we're going to get a table returned to us that is coloring the weekly average based on the z-score information. And that's kind of cool. That's one approach. Ellis, you want to walk
and
through
by the way, just to quickly call out,
Yeah.
we are aware that the column names are off by 1. So this is the weekly. Yeah. Don't know what happened there. Just wanted to make sure to let people know that we're aware of that.
Interesting. I wonder. We must have our go up. You know. Do at the end of CV put comma and then quote Z inside of it, and then run it. And now run this again.
Boom.
Yeah. So we needed to give a name. We needed to give a name to the invisible column so that there was a placeholder for it.
Yeah.
That's all. There we go.
Yeah. There you go. Debugging on the fly. All right. So now rather than so maybe there was a situation where we actually wanted to have more flexibility or more control over the way that it cut. Maybe we wanted to be greater than and equal to rather than just greater than or something like that. I don't know. Rather than using a style interval, we can use a style equals like we used before. So what we're going to do is we're going to take dat2 and we're going to construct a flag column to tell data table once we get to the styling, hey, I want you to style based on these exact values that I already calculated for you. You don't have to calculate anything for me. Mm-hmm. And so this is just going to be a case when. So we're going to do any values that are less than negative 0.4, we're going to call low. Any values that are greater than 0.4, we're going to call high. And any values in between, so that means negative 4 and positive 4 inclusive, we're going to call normal. We're going to then throw it into the data table. This time I'm calling it out as manual coloring just so that we can see this in our data table. The options are the same. I'm going to quickly add in
Add a Z
the
column or
Z
whatever.
there.
Yep.
And then we're going to go down to format style. Again, we're going to use, I want to be coloring the week average or weekly average column, but we're going to be using the flag column to get the values that we're going to be basing it off of. We're going to set the background using style equal, and when it's low, we're going to use the light red. When it's normal, we're going to use white, and when it's high, we're going to use that light green color. So now we can apply this again. And remember, this should give us the same values because we're calculating it the same way. But if we were to have changed it, this is the way that you go about doing it. And, ultimately you could have multiple flags doing multiple things depending on the complexity of the data that you're trying to display. Realistically, keep it on the minimum. You don't want to get too crazy with your styling. Okay, now we're to our last couple sets of examples here. Patrick, how would we gradiently do this? So say rather than we wanted to have a dichotomous high, medium, low, what if we wanted to have it kind of change the colors based on the actual values?
Yeah, so to do that, we need to set up a color ramp. So I'm going to use a few different functions here. The first one is I need to set up the palette. So we're just going to use the standard old traffic light example of red, white, and green. So we set that within the color ramp palette. We set the vector of our colors that we're interested in. We need to set up the breaks for the actual data. So to do this, I make sure that I grab the column I'm interested in coloring, and I set the sort function so that it knows, hey, I want to apply that color ramp palette to these explicit values going from low to high. Okay, and if we wanted high to low, we just reverse the sort. Okay, and then I need to get those colors into a form that data table can use. So I use this function call underscore ramp, and I get the length of the breaks in the data that I'm interested in. And I add this +1. Now, if you do not add the +1, you can run the below table and it will tell you, I don't know what you want me to do because the color ramp needs to be +1 of the breaks. So I don't know why that has to happen. All I know is that it'll kick out an error. So all I do is I add +1 and I get what I want. And
It's because
I'm
we have to
happy with
pass
that.
one more color than exists cuts.
That's what it is. Yeah, one more color than exists cuts. That's the error that you get. So once we have that, we throw that in there, and
we use the style interval.
we use this style interval. The cuts are the color breaks, and the values are the actual colors. And now we have a nice little. That's pretty cool.
Yeah,
Look at that.
it calls them out pretty nicely.
Yep.
80.
And if you sort by that column, you're gonna get, yeah, there we go. That's pretty nice.
Here we go. Here, let's
Cool.
increase this to 50 so we can just scroll on down there for our 15 values. So it's a little choppy because we only have 15 values to be cutting on, but it gets the job done. And there's a lot of values that are the same. 67 apparently is a common thing. Cool.
Yeah.
So that's been a lot of styling. We've now styled columns based on their own values. We've colored columns based on the values externally, either another column in the data set or we passed in some values to cut on. But what if you wanted to color an entire row? We can do that too. So we're going to take that same basic table 2. We're going to format style, and we're going to color on position. So we're going to be using a style equal because position is a categorical forward, guard, center, right? But the new thing that we're going to be adding that's different than what we did in the past is now we're going to be setting up the target equals row. So what that's going to tell DT is I want you to color this entire row based on this value. And again, we're going to be using background color because we're going to be highlighting the background. We're going to use set equal. So when it's a center, have it be white, a forward pale green, guard pink. And now when we run that, we see all these centers. This is anticlimactic because the centers are first, but the centers, it's a white background all the way across. Here, let me actually go to 25. Then when we go to forwards, the background's all green all the way across. And then finally for guards, it's that pink color for everybody all the way across.
Yeah.
And that is how you can use DT to apply a number of different format styles. Hopefully, you now have a way to take and read the documentation and kind of understand what you're supposed to be doing and apply it in a more general sense to all the different styling scenarios that you might be able to come up with. And of course,
Yeah.
you can layer multiple styles too. We only ever used one at a time because we wanted to be very clear about what the exact change was. But of course, you can add multiple formats as you go.
Yeah.
And whatever one, I'm assuming whatever the last one is to be applied will overwrite what's done before.
Mm-hmm.
So with that, that is episode 134 of TidyX, Conditional Formatting in DT. Thank you all so much for joining. As always, my name is Ellis Hughes. You can find me on Twitter at Ellis_Hughes.
And my name is Patrick Ward. You can find me on Twitter at OSPPatrick, at Tidy_explained is where the screencast lives on Twitter. Tidy.explained@gmail.com is where you can hit us up with an email. But of course, liking and subscribing on the YouTube channel is the best way to get in touch with us. You could drop a comment or question down below, and maybe your question will turn into an episode like this one. If our work has positively impacted you in some way and you'd like to donate to our Patreon page, we do have that, and we're always thankful for anything that you may give.
Thank you all so much. Keep on exploring your world.